Dear friends, myself Ritu Singh from Lakshmi Institute of Technology, Saregam. Today I am going to discuss one problem related to mix design. So we are going to discuss one problem for the mix M35. So let's see the problem. See, this question is based on the mix design, and the question here is for the grade of concrete we have M35. Characteristic compressive strength required in field is at 28 days 35 megapascal, that is 35 Newton per mm square. Type of exposure moderate. Design mix target slump, means slump value whatever you have is 150 to 175 mm. Maximum size of coarse aggregate 20 mm. Fine aggregate belongs to zone 3. Specific gravity of cement 2.93, this all you know. Specific gravity of water 1, specific gravity of admixture 1.121, specific gravity of coarse aggregate 2.82, specific gravity of fine aggregate 2.65, water absorption of coarse aggregate is 0.86% and water absorption of fine aggregate is 1.25%, and this is under saturated surface dry condition. So, this problems we are going to solve with the help of IS mixed design, that is Indian standard mixed design. In India we are adapting this mixed design. Okay, so let's see one by one. So here we have 6 steps. This full design is divided into 6 steps. That is, first is target mean strength of concrete we have to find. Then second, water cement ratio we will determine. Third, water content we will determine, and fourth is calculation of cement we will do, and that is fifth, calculation of volume of coarse and fine aggregate content, and design mix calculation. So we all knows that this concrete ingredients of concrete is nothing but cement, fine aggregate, coarse aggregate, water, and now in upgraded version, that is admixture also we are adding. So we will solve accordingly. Okay. So step 1, target mean strength. So you can see here over here, that is F dash CK I denoted equal to FCK 1.65S, where F dash CK is nothing but target mean strength of concrete at 28 days. We are counting always the strength at 28 days, which is in Newton per mm square, and FCK is nothing but characteristic compressive strength at 28 days in Newton per mm square. What is S here? S is standard deviation in Newton per mm square, and 1.65 is a tolerance factor. This I am not saying, but according to your Indian Standard Code 456/2000, if you visit the table, this table 8 of page 23, you will find S5. For what? For your 35. We have mix, that is, you can see here in the question we have mix M35. So in the table, if you go table 8 of page 23, you will find S is standard deviation is 5. So we can calculate here from the we can calculate here. We know that FCK is 35 in the question, and plus we have 1.65 into 5. So 5 is standard deviation. So your answer is, what is target mean strength here? We have 43.25, which is unit in Newton per mm square. So in the first step you got the target mean strength. Okay. So let's for the determination of water content water cement ratio. So step 2 is water cement ratio, means W by C we will find. What is W by C? So this also we have water cement ratio. Maximum water cement ratio is 0.5 according to your IS 456 table 5. So if you visit table 5 of page 20 this of IS 456, your maximum water cement ratio is 0.5. Okay. So but based on our experience, based on practical experience, we adapt water cement ratio as 5% less. It means, what it means, that if you have from the IS code, if you have this water cement ratio as 0.5, but in the practical experience you will decrease this by 5%, as we know that if you decrease the amount of water, your strength, your durability, your permeability will be okay, and hence your strength will be okay. So we always try to take a minimum water content. Okay, so here it is maximum water content, so we will reduce this by 5%. so here what we will do, 0.5 we have minus 5% means 5 by 100. Okay, so here you will get this 0.5 minus 5 by 100 is nothing but 0.05, so equal to 0.45. So here actual water cement ratio we will adapt as 0.45. Is it okay for you? Okay, we'll move to the next. Now this determination of water content. So first of all we got the target mean strength, secondary we got the water cement ratio, and the third step we will determine the water content. Okay, so this water content, you have water content, this also from you should see two code based on this IS mixed design. One is Indian standard 10262 2009 and other is IS 456 2000, that we have already gone in first and second step. So here we got the this water content for your in the question you might have observed, see here in the question you might have observed that your maximum size of coarse aggregate is 20 mm, and here target slump, your mixed target slump is 150 to 175 mm. So based on this we will have water content. Okay, so according to your this IS code IS 10262 2009, that is on page 3 table 2, it is mentioned that your maximum water content for 20 mm coarse aggregate is 186 liter, and this value is also mentioned for just 25 to 50 mm slump. Okay, so this we will calculate according to our given data, that is 150 to 175 mm slump, this is given in the data. So and it is also given in the IS 10262 page 2 of clause 4.2, it is given that we can increase 3% for every additional 25 mm slump. So here what we will do, we will increase the amount of water for every 25 mm slump. Here water is 186 liter, we have noted for just this 25 to 50 mm slump, but we have to calculate water content for 150 to 175 mm slump as given in our question. Okay, but according to this IS 10262, it is given that we can increase 3% for every additional 25 mm slump. So here we can calculate the amount of water like this. For example, we have 75 for 3% increment, then every 25 I will increase, so 100 for 3% increment, then 125 for 3% increment, then 150 for 3% and 175 for 3%. So how much total increment I got? That is 15%. So what I will do? I will increase the amount of, here I will write, I will increase this amount of water by 15%. Okay, so what I will do, 186 water I got maximum water content plus 186 into 15%. Okay, so total water I will get here as 213.9 liter. Okay, you can calculate by your own, but this is not the final answer, final amount of water calculated. We have also given that deduction of water by 15% with the use of admixture. This clause only we have given, this deduction of water by 15% with the use of admixture. So we can calculate actual water use. So what deduction I can say, 15% if you are using admixture. In the question it is given admixture also. See here, admixture is given, I am not written here. So admixture is given in the question. I will calculate according to admixture. So it is given in IS 10262 this clause that deduction of water by 15% with the use of admixture. So what I will do, with this amount of water I will deduct 15%. So here I will calculate. Now my water is this one, 213.9 minus 213.9 into 15% by 100. Okay. So what I will get as 181.82 liter as actual water I have. Okay. So this water content I calculate. Now next step is that calculation. Next step, that is fourth step, is calculation of cement content. So cement content, this minimum cement we have 300 kg per meter cube. Not this I am not saying, this said by IS 456 2000 page 20 table 8 for moderate exposure. So in the question we will design according to our question. So in the question it is given, you can see moderate exposure. So for the moderate exposure our cement content will be 300, this is minimum 300 kg per meter cube. So we can calculate actual cement content. So what is actual cement content? How can we calculate? We have water content, we have water cement ratio. So how much water content we calculated earlier? You can see here 181.82 liter. So 181.82 liter by water cement ratio, how much we have? 0.45 actual. So we can have 0.45. So how much cement I will get? I will get as 404 kg per meter cube, which is greater than this 300. Okay. So hence it is okay. So this data will be greater than we have in IS 456. Understood? So from the next, this step 5 I will discuss in the next lecture. Thank you. Hope you understand till now. Thank you.